Hello everyone, thanks for joining this session. We are going to address here Ceilometer and Cloudkitty and Gnocchi and how one can leverage them to build a dynamic and agnostic cloud monitoring billing solution. Just an outline of the presentation that we're going to follow here today. We are going to start with an introduction with respect to cloud billing and how one can perform that and why one needs that in the different modes that we have. And then we're going to showcase the billing stack that we implemented with the Openstack components, Ceilometer, Gnocchi, and Cloudkitty. And then, of course, we're going to finish with a conclusion with some takeaways. Just a brief introduction about myself. I'm a cloud consultant and enthusiast. I am a PMC and committer for the Apache Cloud Stack, which is an alternative project for Openstack. But nonetheless, I have been contributing for Openstack since 2018. And I'm a core reviewer and the next project team leader for Cloudkitty. The sponsor that is driving all of the extensions we are doing in Openstack, not just in the billing aspect of it, but even in Neutron, in Keystone, we have some other extensions that we're implementing. The company that's sponsoring all of this work is Everywhere, and they are one of the leading cloud providers in Switzerland with more than 3,000 business customers and over 20 years of experience delivering business critical platforms. And the interesting part is that because of the business they deliver, they have some very specific requirements, which pushes us to deploy a very complex and heterogeneous cloud computing environment. So just to give you guys some idea, at the same time, and because of some different business requirements, they have running CloudStack, OpenStack, vCloud, and many other different systems that are used to build their cloud environments and to deliver their business. So just a brief introduction about the environments we are dealing with. They are heterogeneous, vast, complex, and dynamic. And that means we need to handle different types of devices, different types of virtualization systems, different types of networking, storage systems, and of course, many different applications that are delivered to the users. When it comes to cloud billing, in the context that we are working on right now, basically the cloud billing systems, they are the ones that are collecting users' data, and these users' data can come from storage, network, processing, VPN, users, and many other different resources that we have in the cloud environment. And after the collection, we have the data processing and rating phases. And these two steps, they need to scale easily. That's one of the requirements we have when implementing such billing systems. We should also be able to add new metrics on the fly. And also, of course, support different pricing for different consumptions of the same resources, and also support data transformations, like whenever you are transforming somehow string data that you are capturing in some value or of some sort, and also, of course, a change between different scales. So what are the options that we found when we were looking for such a billing system to fit all of those requirements? Basically, we found billing portals, and these portals, they would create an abstraction on top of the cloud computing orchestration system. And they would connect all of the applications and perform data collection, rating, billing, invoicing, client onboarding, and user management, and so on, and many other different features, like some predictive analysis of the environment, some forecasting for the resource consumption, and so on. After analyzing these different systems, why didn't the client that we are working with adopted the cloud portal system? Well, basically because those are all normally proprietary solutions. At least we did not find any good open source solution out there, and they are not easily customizable. And so, we need to add new metrics on the fly. We don't actually, when we started 2 years ago, we didn't know all of the metrics that we are using today. So therefore, the proprietary systems, they did not feel that easy to extend and to customize. And when we say customization here, we're not talking about, changing icons and CSS and so on. We are actually talking about the type of metric that the system monitors, stores, and then, uses for billing. And also, whenever integrating a new system or a new device or a new application. Of course, some of them they support a variety of different application systems, but nonetheless, whenever we would need to add a new one, for instance, we would need to raise a ticket, discuss, how this implementation would be executed and the cost and so on. So that would make them a little bit slower to support new metrics and new integrations that they need. One alternative to cloud portals is something called monetary quota, and that's a feature that I have seen applied only, so far at least, only on Apache Cloud Stack. The idea is that you limit the use, like quota, you limit the use of computing resources for a user based on a monetary value. So instead of limiting the amount of virtual machines, for instance, that the user can deploy, you actually assign the user a value, like a credit, and then the user can consume that credit by using and allocating virtual machines. And each one of the resource that the user allocates has somehow a monetary value that's attached to it. Well, for us, for this specific client, that did not work because the model, this type of model is intended for private cloud use, because the client is actually a public cloud model, and we need something to mimic the pay-as-you-go, which is actually the public cloud model. That would not fit. And also, Openstack did not have this implementation built in, as far as I know, at least. And last, the last model that we were discussing and we evaluated is the idea of rating. So the rating is just about, assigning a monetary value, a price, for the consumption of a computing resource or a cloud computing resource by a client and in a given time. And then these applications, they would normally generate reports, showing the amount of resource that was consumed and the monetary value for those resources that the user consumed. That's the model we adopted, and it fits nicely in the public cloud model, the pay-as-you-go model. And OpenStack has a component called Cloudkitty, which is a rating as a SaaS module. So it fits nicely the requirements we were working with. The chain that we implemented, of course, here we are, for instance, hiding the parts that after Cloudkitty, we have like an ERP, another system of the company that are getting these resources that were rated, that had a monetary value assigned to them, and then generate the invoicing and send to the client. But basically, we have the cloud environment with all of the different resources that one needs to handle, like identities, user connections, object storage, computing resources, and so on. All of those are monitored in different systems as well. For instance, vCloud is a different cloud computing orchestration than OpenStack. And then we have Ceilometer monitoring, gathering data there and persisting in Gnocchi. And after the data is persisted in Gnocchi, it's consumed by Cloudkitty, so we can rate it, so we can assign a monetary value to it. That's a very simple stack. All of the components, they are open source, which is interesting, and we can extend quite easily. Of course, we implemented this, but this is not just what we have in production, because as soon as we started implementing it, we found some limitations. So for instance, Ceilometer was not able to create new metrics on the fly. All of the metrics that Ceilometer had built in, they were hard-coded, meaning there is a Python code that is executed and that collects and handles the metric. And that was a problem because we wanted to be able to generate new metrics, meaning collect data from different APIs and from new APIs in runtime. And that was not possible when we started working with Ceilometer. So to overcome that, we created a new subsystem, a new feature in Ceilometer, which is called dynamic posters. Basically, the idea is that one can define the posters, the agents gathering data in Ceilometer via YAML. So basically, you declare the OpenStack API that you want to call, the parameters you want to retrieve and how you want to process them, and then you store them in the backend. And in our case, the backend is Gnocchi. So that's the first extension we did. And then we noticed that, okay, we want to monitor not just Openstack resources. As I explained to you guys at the beginning, the sponsor has, a very heterogeneous cloud environment, which means that we need to be able to monitor different systems at the same time, and ideally with the same billing pipeline that we were building. So we extended the dynamic posters in Ceilometer that we created even further, meaning we enabled the dynamic posters to monitor any API that we want, as long as they expose a JSON format. I put an asterisk here in this implementation because Ceilometer had an integration with the Rados gateway before with S3 protocol. But as the hard-coded poster, it was something written in Python. You could not actually easily extend. And when I say easily extend here, I'm talking about the operators, because somebody from the that's operating this whole infrastructure, they might not be that familiar with Python or might not be that familiar to extend this type of modules. Therefore, for them, it's way easier to configure a new poster. That's what we introduced with a dynamic poster using YAML, for instance, then coding the poster with Python. And by delivering these two implementations, we are able to monitor basically any type of API that responds JSON with Ceilometer right now, even if the API is not an OpenStack. And if the API requires credentials, requires authentication, for instance, Ceilometer has a built-in integration with Barbican that we also introduced. So all of the credentials are safely stored in Barbican and retrieved by Ceilometer and then used to connect to the system that we are monitoring. So it's a quite solid and secure monitoring chain that we extended Ceilometer to have and to support. After Ceilometer, we started noticing, because we put the system in production and then everything was nice until it was not. So for instance, we started noticing that Gnocchi was not returning the right version for the attributes of the monitored resource. By right version of the attribute, here's what I mean. For instance, the flavor of a virtual machine, it's stored in Gnocchi as an attribute. If the flavor changes in the middle of the month, for instance, and if we do a reprocessing for that month, Gnocchi was always returning the latest metadata that was stored there. And that's a problem, because then instead of using correct value for the rating, we were using the wrong one, the wrong information to define the price. So we had to fix that for Gnocchi as well. And after fixing that, and of course, we still continued moving on, and with the system up and running, we started noticing some slowdowns in Gnocchi, and that was happening because of the database schema that was implemented to it. So we had to improve and to optimize some of the Gnocchi's database schema as well to support the growing data sets that we have. Last but not least, we also extended Cloudkitty. First, we needed to introduce the support to the rateXX aggregation method in Cloudkitty, because Cloudkitty was not properly using them. So the rateXX, these are some options in Gnocchi that allows you to calculate the rate between two data points in time. And Cloudkitty was not actually executing that use of the API properly when these aggregation methods were being used. Then we fixed that as well. And last but not least, the usage reports. Cloudkitty had a fixed usage report model, meaning it would only return the resource ID, quantity of the resource that was used in hours, and then the price. But for our use case, we wanted to be able to retrieve, for instance, the metadata, the attributes that are stored there in Cloudkitty as well. So we extended this API to allow integrators and other people consuming the Cloudkitty API to retrieve the metadata that is stored to it as well. So whenever you retrieve, for us, whenever we are retrieving data from Cloudkitty, we are able to retrieve not just the price and the quantity, but also the metadata attached to those rating information. And then we can, generate more meaningful reports there. In conclusion, we were able to build a very solid and open source billing pipeline with Ceilometer, Gnocchi, and Cloudkitty. And that's interesting because we are able to monitor and build all of the cloud resources. So it's not just about OpenStack resources, but also everything else that we have in the cloud environment and that's supported by this pipeline. We have a limitation right now that's worth mentioning. The extensions that we did in Ceilometer, they are not able to monitor XML APIs. So for instance, the vCloud that we have right now, the data is captured by some scripts and then persisted in Gnocchi. But after the data is in Gnocchi, Cloudkitty rates them as we rate any other resources. So that's one of the last extensions that are missing in the dynamic poster subsystem that we introduced in Ceilometer. And this setup is stable and solid, and it has been running for over 2 years already. We keep improving and working with it. And not all of the implementations, but most of them that we did, they are already in the upstream and they were already released. For instance, Ceilometer, all of the implementations we did in Ceilometer so far, they were already released in Victoria release of Openstack. In Gnocchi, some of the pull requests were merged, some of them are still open. We do know that Gnocchi is in like a gray area right now. It's not part of Openstack. It's not a component from Openstack, but it's quite heavily used, and there is a movement to somehow bring this type of system back to the community. But so far, when we fixed those limitations, we propose the fixes back to the Gnocchi project in GitHub. And in Cloudkitty, there is, I think, one extra pull request, merge request that's still open there, but you know, it's coming at least probably in Wallaby release. And for the future, we are only missing one thing, one step, to be able to build a full-blown cloud portal with open source, and that's what we are working on right now. So basically, we have developed a customer onboarding and management portal that enables us, you know, to do the user onboarding, to manage the users, and to integrate different systems in the cloud environment, and to provide that unified view of the cloud computing environment for the end user. We are right now testing and validating it internally, and the system will be open sourced in the coming months. That's basically all of my presentation. Thank you guys for watching it. And if you have any further inquiries, questions, you can just ping me and send me an email in my private mail account, and I'll be happy to reply to you back.